This slide is the C part of the previous slide in question number 3, worksheet number 4, chemical reactions. In the A and B part, we were asked to write a balanced chemical equation of the reaction between sulfur dioxide and oxygen, producing sulfur trioxide, and we were asked to find the excess and limiting reagents. We had determined that sulfur dioxide was the limiting reagent and oxygen was the excess reagent, where 1.5 mole of oxygen was excess. Now, in the C part of this question, we have to draw 3 graphs. The first graph is mass of oxygen versus time. That means how the mass of oxygen changes as time goes on. On the time axis, I'm going to determine a time t, and I'm going to say that this time is when the reaction finishes. At the beginning of the reaction, we know that we had 2 moles of oxygen. That means 64 grams of oxygen in our closed container. As time goes on, we had half a mole of oxygen reacted, and when the reaction was finished, we had 1.5 mole of oxygen in excess. 1.5 mole of oxygen makes 48 grams of oxygen because the molar mass of oxygen is 32. Now, we can draw the graph saying that we started with 64 grams. As time goes on, the mass of oxygen decreased, and when the reaction was finished, we ended up with 48 grams. After that, the reaction doesn't take place and the mass of oxygen stays constant. Total moles versus time. We can see again from the equation that we had initially 1 mole of sulfur dioxide and 2 moles of oxygen, totally 3 moles of gases. As reaction went on and the reaction finished at time t, the moles of gases decreased from 3 moles to 1 mole of product and 1.5 mole of excess oxygen. That means 2.5 moles. So here is our 2.5 moles. Now let's draw the graph. 3 moles decreases to 2.5 moles at time t when the reaction is finished, and after that the moles stay constant. The third graph is for the density of the gases in the container versus time. If you look at the masses of the gases in the container, the total mass is equal to 64 plus 64, 128 grams. Density is mass over volume. And at the beginning and end of the reaction, because mass is conserved, this 128 grams stays constant. So we can say that density in the container is equal to 128 grams over the total volume of the container in centimeter cubes, which is 1000 centimeter cube. In that case, the density will come out to be 0.128 grams per cc. We can identify a point on the graph and call it 0.128 grams per cc. When the reaction starts and when the reaction finishes, the mass in the container doesn't change, so the density stays constant. I would like to remind you that because mass is conserved in chemical reactions and because this is a closed container, the density at the beginning and end of the reaction and even after that stays constant. Thank you for watching and listening.